Okay, so 3.3 rational functions. So I'm going to start from the beginning, but I'm going to go through it a little bit quickly because we've done it together today, okay? So rational numbers are any ratio of integers. A ratio of integers is just a fraction. So any number that can be written as a fraction is a rational number, like 2 over 3, 3 over 7, 5 over 1. Those are all rational numbers. What's not rational would be like root 2, root 3, root 5, root 7, pi. That's not rational either. So that means that rational functions is a ratio of polynomial functions. So something like, x squared plus 1 over x. So something like that, right? So it's a polynomial function on top, polynomial function on the bottom. Technically, even if you had like x plus 1 over 1, those are polynomial functions. So that's a rational function. So this says when P and Q, when the top and the bottom have no common factors, there's nothing that can be divided away, we say that R is in lowest terms. Okay, and then two things, but one of these we fixed today actually. So if R of X is in lowest terms, then to find the vertical asymptote, we set the denominator equal to 0. And then here we just fix something a little bit. The domain is always going to be negative to positive infinity, excluding any vertical asymptotes and any holes. So holes and vertical asymptotes do not go in the domain because the domain is what's possible. Vertical asymptotes are not possible and holes don't exist. They're like black holes. They don't exist. Okay? Or we can't see them. How about that? Okay, so number one, find the domain and vertical asymptote of each. Okay, so for this one, so you have 2x squared minus 4. If you factor the top, you get 2, and then x squared minus 2. Okay, and then on the bottom, you have x plus 7. There's nothing to divide away. It's in lowest terms. So your vertical asymptote is x equals negative 7, and your domain, this should have probably like a comma. Your domain is from negative infinity to negative 7, from negative 7 to infinity. Okay, done. That's A. Okay, how is B going to look different? Okay, so for B, I'm going to go like this so it doesn't you don't see too much of it. So for B, we start off this way, and then what I said was, okay, now go ahead and factor and see what happens. So when you factor and see what happens, you see that that was not in lowest terms because what happens is you would factor the bottom and you get x minus 3 over x minus 3 times x plus 3. So really, this turns into 1 over x plus 3, right? When you cross out the x minus 3's, you get 1 over x plus 3. This would be lowest terms of this r of x, okay? If you're crossing out the x minus 3 over x minus 3, that's where your hole is. So my notes are a little bit off, so I'm going to say it out loud what the final answer is. Are you ready? So, go like that. So you have a vertical asymptote at x equals negative 3. Where did that come from? That came from what's left over after you reduce. So x equals negative 3 is where your vertical asymptote is. The hole is at 3 comma, so it's 3 because that's what you crossed out. X minus 3 is the factor, which means x equals 3 is where the hole is. So 3 comma, how do you get a 1/6? Well, you plug it into here, which is in lowest terms. So if you plug a 3 into here, you get 1 over 6. That's how you get the y value of the hole. And then right here they said, to find the y value, plug in the lowest terms. Okay. So what does this look like? What does this look like compared to that? So I'm going to show you what this looks like. I want you to imagine in your head, what does 1 over x look like? 1 over x, not with this, right? Just 1 over x is a hyperbola. So it goes like this down on the left side. I need you to realize what that looks like. When it has an x plus 3, it means that it shifted to the left 3. So this is a hyperbola shifted to the left 3 with the hole in it. What that really looks like is that. So it's a hyperbola shifted to the left 3. So instead of having a vertical asymptote here, there's a vertical asymptote at x equals negative 3. And then there's a hole at 3 comma 1/6. So this looks like that. The reduced form, if it didn't come from this, if it was just this problem itself, would look exactly the same, but without a hole. That's what happens when you cross out top and bottom. You get holes in there, okay? So now we're going to start talking about horizontal and oblique asymptotes. So keep in mind, horizontal is like the dot, 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 right, across. Oblique is when you have a diagonal. It doesn't matter which direction, but it's some sort of, y equals mx plus b, right? So it's some sort of line that's a diagonal. So there's 4 things that we care about. There's 4 cases. The first one is the top degree is less than the bottom degree. So for example, x to the first over x squared. That would be this. That means that the horizontal asymptote is y equals 0. Look at this graph. Oh yeah, look, there's a horizontal asymptote at y equals 0 at the x-axis, right? That's what y equals 0 is, the x-axis. All right, what if the top degree equals the bottom degree? Well, if the top and bottom are the same, like if this is x squared and this was x squared, then that would be the same degree. And then what you would do is y equals, you'd have a horizontal asymptote at y equals the ratio of the leading coefficients. So I'm going to show you an example of this a little bit later. Okay, the next case is if the top degree is 1 bigger than the bottom degree. So if this was like x cubed and then this was x squared, it would be case 3. If it's case 3, you get an oblique asymptote. That's one of your diagonals, y equals mx plus b, basically. And then what you would have to do is you'd have to find a quotient. You have to divide and find a quotient. So I'll show you one of those in a little bit. Okay, the last case is if the top degree is bigger than the bottom degree by more than 1. So if this was like an x to the 4th or an x to the 5th, then it's more than 1 degree higher than x squared. That means that there's no horizontal asymptote, there's no oblique asymptote. Okay, so let's say you have something like this. So for A, you try to factor, and when you factor the top and factor the bottom, there's nothing to cross out. Okay, so I'll say it that way. There's nothing to cross out. So you can't factor the top. It's not going to work for you. All right, then, well, what case is this? First of all, this is an x squared. This is an x squared. Oh, that's a case 2, right? Same degree on top and bottom. If you look at the degree, it's the biggest degree. It's always. So then this is case 2, and you're taking the ratio of the leading coefficient. So -8 over 4, which is -2. So your horizontal asymptote is y equals -2. How do you find a vertical asymptote? Because you're looking for all asymptotes. Well, a vertical asymptote is you look on the bottom, you go ahead and either factor or set it equal to 0 and solve, and then you get a plus or minus. Don't forget about that plus or minus, and then now you have 2 vertical asymptotes, 1 horizontal asymptote. If we were going to draw this, which we are later, okay, in like a couple minutes, that is really helpful, and then we start drawing after that. Okay, for part B. So for B, what are you going to do first? Try to factor. If you try to factor this, there's nothing to cross out on top and bottom. But then also, let's see, which case is this? So this is an x to the first, this is an x squared. Oh, top degree is less. Oh, this has a horizontal asymptote at y equals 0. And then let's go ahead and get the vertical asymptotes, see if there's any holes or anything. So you factor the bottom, and you get this, and there's nothing to cross out on top and bottom, which means they are both vertical asymptotes. So you have 2 vertical asymptotes and 1 horizontal asymptote. Okay, let's look at C, which we did not do together in class. So if you look at C, it says h of x equals 3x to the 5th minus x squared all over x cubed plus 1. Okay, thinking about the cases, when you look at this, it's x to the 5th, and then this is x cubed as your biggest degree on top and bottom. So this is more than 1 bigger than this degree, so there are no horizontal or oblique asymptotes. And then I try to factor. So if I try to factor, I can factor out an x squared, and I get this over this. Can I divide those away? No, they are not the same. So really, I just look at the bottom for vertical asymptotes. So set the bottom equal to 0, solve, and you get one vertical asymptote. So no horizontal or obliques, but you do have one vertical asymptote. If you put this into the calculator, you would see one vertical asymptote, and that would be it. Okay. And then D, we started this together, or we did this one together actually. So this is x cubed over x squared. That's the most important part. X cubed over x squared. So the top is bigger than the bottom by 1. That means this is your case 3. You have to do some division. So it's been a long time since we've done long division. So reminding you about long division, you have to do literally, like, remember long division? So that's what we're doing. So I'm going to block this out, and you're dividing 2x cubed plus 1 by x squared minus x. How come there's a 0x squared and a 0x? Because they are placeholders. You want to have all of your terms there, even if they're just placeholders, right? So you want to have them all there so that when you start doing your long division, you know where to put the right stuff. So I put it actually in the wrong place. So this 2x was supposed to go over the 0x, and when we did our notes together, I put it in the right place. But I even put it in the wrong place. Does it matter? It helps you, that's all. Okay, so what am I really looking for? What times this equals this? So what? 2x, right? If I multiply this by 2x, I get 2x cubed. So that's why the first is 2x. Again, I would put that 2x over the 0x actually. Okay, so 2x times this is going to be 2x cubed minus 2x squared. You subtract down. That's how you do long division. And then when you subtract down 0 minus a negative 2 is positive 2. Bring down the 0x. And now you think, how do I get this to look like this? Oh, I multiply by 2. So that's why plus 2 is my next number. So multiply by 2, this one, and you get this. You subtract, you get 0. You subtract a negative, and you get positive 2. You bring down the 1. This is your remainder, so you write it as plus, technically, the remainder over this divisor. Is that a divisor? I think so. Okay, so what your final answer, and then this right here is to get your vertical asymptotes. Okay, so set the bottom equal to 0, get your vertical asymptotes. Okay, what your oblique asymptote is this portion over here. So we ignore the rest. What we care about is this portion. If I ask you to divide, you want the whole thing. But if I ask you for the oblique asymptote, you only really need to get to here. You don't really need to get to your remainder, right? Okay, so final answers. Oblique is y equals mx plus b, basically. And then vertical is two vertical lines. Okay, so now I'm going to show you how to graph, all right? Ready or not? Here we go. So let's say we're graphing y equals 1 over x squared. So the first thing we want to look at is, what is the horizontal asymptote? How do I know it's y equals 0? Because the top degree is less than the bottom degree. So that was, I think it was case 1. I'm guessing, I think it was 1. So top is less, okay, y equals 0. Got it. So that's going to be really important for me. I can actually draw that in already. Okay, what is the vertical asymptote? So we still want to do that first. See how we've been practicing that, but we want to do this first before we start graphing. So you set the bottom equal to 0, you get x equals 0. Okay, that means that you're going to do dot, 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 dot. So what you want is you want to make a little t-chart. You want to make a little xy with at least 2 numbers to the left of your vertical asymptote and 2 numbers to your right of the vertical asymptote. So right here I have, oops, my vertical asymptote, which starts at x equals 0. So for 0, if I put it in here, I get nothing, okay? I want to go 2 to the left, 2 to the right, whatever those numbers happen to be, okay? So it doesn't have to be -2 and +2. It's just wherever I start, I go 2 to the left and 2 to the right. And then I literally plug in and then use my t-chart and, write my answers. Okay, so using these points, I draw my asymptotes, and then I draw these 4 points. When I draw the 4 points, I get this one and this one and this one and this one. I follow my asymptotes all the way down and up. I follow them up and down. So I cannot cross a vertical asymptote, so I just follow it up. And then I cannot, at the end, I cannot cross a horizontal. Well, I can cross it, but I have to follow it, basically. So the horizontal, I have to follow all the way to the left, follow all the way to the right. This is what that graph looks like. If you put it into the graphing calculator, I swear you get that same thing, basically. Okay? So then over here, these are called limits. I want you to write limits for every single graph that you draw. I want limits. So let me talk about limits. Limits are basically end behavior and also what's happening next to the vertical asymptote. So something like this, on the left side and right side, I'm going to have 2 limits, one on the left, one on the right. And then I look for my vertical asymptote. Each vertical asymptote, I want 2 limits. So that's 4 limits total. Okay? So how do I write my limits? So I'm going to number them here. So this is one of them, another one, another one, and another one. Okay? So how do I write it? The limit, so that means like, well, let me say it first. The limit as x goes to 0 on the right side. So the limit as x goes to 0 on the right side. Literally, I'm looking at x equals 0. So I just look at x equals 0. And then I look on the right side. Do you see that arrow pointing up? So arrow pointing up means y is getting bigger and bigger and bigger and bigger. What does y is getting bigger and bigger and bigger and bigger mean? It's positive infinity. The y value of h is positive infinity. So that's why the limit as x goes to 0 on the right side is positive infinity. The limit as x goes to 0 on the left side, so I look in the middle, and then I look a little bit to the left. Literally, that's what I do. I look a little bit to the left. See how the y is going up? There's an arrow going up. That's why that's also positive infinity, because the y value, h of x, is becoming more and more positive on the left side of that asymptote. Okay? This is how literally you say it. You say the limit as x goes to positive infinity of h of x is 0. What does that mean? The limit as x goes to positive infinity is the end behavior on the very right side. So literally you're looking at the very right side because that's where x gets bigger and bigger and bigger. So when you look at the right side, what's the y value getting really close to? The y value is getting really close to 0. That's why the answer is 0. On the left side, what's happening? It's getting closer and closer to 0 as well. Okay, so this says the limit as x goes to negative infinity. That's why it's on the left side, because this is negative x's, of y is 0. Okay, so these are basically y values, and limits are like, what is the y value at that place? So to the right of this vertical asymptote, just to the right, the y value is positive infinity. To the left, the y value is positive infinity. On the very right side, the y value is 0. On the very left side, the y value is 0. So that's what those 4 limits represent. Okay, you're going to use limits to describe every single graph, and that's why I included that into like today's attachments as well. Okay, and we can talk about that more tomorrow, but I want you to know that you have to do limits. Okay, so let's look at this one. So y equals 1 over x minus 2 quantity squared plus 3 at the end. Okay, don't multiply that out. Don't be a sucker. So instead, you're going to think, okay, what do you do here? So you can do this a couple different ways, but you're still thinking, what case is this? This is a 0 degree on top, and this is a 2nd degree on the bottom. So your horizontal asymptote, sorry, is still y equals 0. Where is that? I didn't write it down. Your horizontal asymptote is still y equals 0. But your vertical asymptote, how would you get the denominator to equal 0? Well, x would have to be 2. So your vertical asymptote is x equals 2. Okay? Or you can think of this as, do you notice it's exactly the same thing as this, but with shifts? So you can think of it that way as well. So you can do this, and then you can plug in a 2 here and go to the left and the right 2. Or you can realize that this we just drew with a horizontal shift to the right 2, and then a vertical shift up 3. Okay? Oh, sorry. So this, but then, sorry, it says plus 3. So that's why it's a y, y equals 3. There, sorry, exclamation point. Okay, so that's why there's a vertical shift up 3, and then this goes right 2. Okay, so you can tell right here with your transformations. And then, oh, I wrote that in here, so same kind of thing. Okay, and then you're drawing exactly the same thing, but shifted to the right, and what else? Shifted up, okay? So shifted to the right and shifted up. There you go. But drawing exactly the same thing otherwise. So it's just with transformations, right? You're translating it to the right and up. Or you can do a little XY chart and you would still get those, all right? So it's up to you. Okay, so now let's look at these limits. How many limits, first of all? Well, there's a left side, there's a right side, so that's 2. There is one vertical asymptote, so the left and right of the vertical asymptote is another 2. So there should be 4. Okay, so what's happening on the very left? What's your y value? It's 3. What's happening to the very right? What's your y value? It's 3. What's happening to the left side of this this vertical asymptote? So if I look at the vertical asymptote just by itself, and then I go like this and look at the left side, see that arrow going up? That's positive infinity. What if I look a little bit to the right? Oh, that's positive infinity also. My answers for my limits, before I even write them and show you, are going to be 3 and 3 and positive infinity and positive infinity. Okay, what do they look like? It should look something like this. I'll number them. So this is my first limit, my second limit, my third limit, my fourth limit. So when we're to the right of 2, so here's x equals 2, a little bit to the right of x equals 2, positive infinity. A little bit to the left, positive infinity. What about on the very right side? X goes to positive infinity. On the very right side, y is 3. And on the very left side, y is 3. So those are limits. I want you to write limits for every single graph that you draw, okay? So the last thing I want to mention, and I already mentioned it in class, is you can never, ever, ever cross a vertical asymptote. So a vertical asymptote, you're never going to cross. You're going to stay to the left of that vertical asymptote and to the right of that vertical asymptote, okay? But horizontal and obliques, so this one, and if it had any obliques that go diagonally, they only help you with end behavior. So technically, like sometimes the graph can start up here and then cross down and then kind of go back up and then even out along that horizontal asymptote. So you can cross horizontal and obliques, but you will never, ever, ever, ever cross vertical. But it's really helpful to have these anyway, because at the very end, on the very right side, on the very left side, it will follow these asymptotes. It's just sometimes in the middle, it gets kind of wobbly and weird things happen. Okay? So we will talk more about this tomorrow. Good luck.